I'm trainer by last name. I'm here from Hamburg, working at Ubi Labs and doing mostly web development and yeah, sometimes CouchDB stuff. And by the way, we're looking for talented developers, and we are also sponsoring the event. And if you're looking for a nice place to work here in Hamburg, just give me a note. Okay, end of advertisement. So CouchDB 2.0. So what have I prepared for this 20 minutes or something? So I haven't prepared any slides. I've thought about like doing some introduction about all the technical internals and stuff, but actually I thought it would be more interesting to you to just see some thing of the future CouchDB 2.0, and I just want to encourage you to get your hands dirty. So let's see if it works out. Okay, CouchDB 2.0. So what's its main feature? It's clustering. So what I've done now is like I've prepared a cluster of 3 nodes locally here on my file system. So here you get like node 1. Sorry for that. Oops. Node 2, node 3, and so can you see that actually? So what has changed like regarding, so I'm here in the installation directory of CouchDB of the current master, like I installed it here locally, and what's different to current to the last CouchDB release. So it's in the file system you can see like you get a bin directory. So you get like CouchDB there, it's the start script, and then you get a strange directory called ERTS 6.2, and actually it's an Erlang runtime system, which is like yeah, which is self-contained and it's got everything that is needed for CouchDB, and which is kind of nice because like we are going towards the direction that we can like create releases that can contain, that are self-contained, that are containing all the dependencies that we need. So the nice thing is for you as developers is that you can like just build CouchDB, take this release artifact, drop it, like build a tarboard, drop it on some server, and providing the fact that this, you build it with the same like architecture and operating system, it just works there. So you can move it around, and that's like a nice thing. Also, it's great for like distributors, for example, because it should ease it up to like, for example, the DDM packages, whatever. And also a nice thing is that we are getting more independent of Erlang versions, because Erlang is pretty, like the Erlang VM is actually pretty stable, but like some, for example, with people like Cloudins are at some requirements you like find some, you will run into some weird bugs as soon as your requirements become very special, like as soon as you get some huge load on your systems, like some tiny changes in scheduling, for example, will affect the behavior of your system, and then you get really, or like that can sometimes make a big difference between even like minor Erlang versions. So we can like ship CouchDB with the Erlang version that we know that is that works good. So that will make it also easier for us, or like CouchDB developers, to maintain and support CouchDB. Okay, so also you got like etc, and it's a directory that only contains like configuration files. I will get to back. Yeah. So also like log directory, of course you got log files, releases. It contains actually. Oh, you can see that actually. Sorry. So that's another directory that contains configurations that's not that interesting. Okay, and then you get like var lib whatever that contains the actual databases. So the point is that everything is self-contained here in this directory, and the interesting thing for us now is like the configuration, and which I'm just gonna show to you. I will explain a few bits. Like, of course, you got some directories that, like some configuration for like database files and so on. And then you got what's actually new. Like, so most configurations might look familiar to you, or like to you if you have ever looked into CouchDB configuration files. But actually new is this cluster section, where you get a Q, R, W, N parameters. So what do they actually mean? Q means like the number of shards in the cluster. So like if you get databases that don't fit like onto one server, for example, or like the load is too high, like you can shard your database across several servers, and this is the number of partitions, and this is actually the maximum number of shards. So if you plan to get like a huge growth of your, like you want to grow your system, and you expect like huge increases of load, you should, or like yeah, you should probably take a like configure a higher value than 8, because 8 is then the maximum number of shards, and you probably want more at some point. So R is the number of reads. Like if you read from a cluster, like at least 2 nodes are being requested, and the same for W, and N is the number of like total replicas in the cluster. So CouchDB will make sure that each datum that you store in the cluster will be replicated to exactly 3 nodes. And here, like 2 says that it's replicated to at least 2 nodes, which is kind of interesting, which is not always true if you get, for example, network partitions. So CouchDB currently chooses availability in favor of like consistency. So you will see an example soon.
I'm wondering why there isn't a more verbose name for it, more descriptive name for it. Rather
yeah, well, you're right. We maybe a comment would also fix that, like, or write or whatever. Good point. I agree.
Everything else has, very verbose.
Yeah, so this is a like developer preview, whatever. So this is the thing as it is, and you're welcome to fix that. So what's also new is like this CHTPD section, and you're probably familiar to this port. And then like what I did with like cluster, because I'm running the cluster locally on my laptop here. So I've set up like multiple instances on several virtual local interfaces. So I can show it to you if I say like IP show. So I've got like 3, like not only 127 like 001, but also 11, 12, 13. Because I got 3 cluster nodes, and I like node 1 is like 11, node 2, 12, and so on. So I've configured that here, and then there's also like this HTTPD section that you know from, or don't know from like current from the most current CouchDB release. So this is kind of internal. So you get a clustered interface. The point of that is that you're always gonna reach the cluster via that interface. So for example, if you do a read request, at least, for example, if you get this R parameter 2, like at least like 2 nodes are being requested in the cluster. And if you just wanna like address like one cluster, it's like there's still this port open, like 5986, but it's actually something internal you should normally not care about. I'm just mentioning it anyway, so in order to, like, you will see later a example like where you sometimes might need it, like depending on the tooling we're gonna provide, you might need it to configure your cluster. Okay, so here on node 2, it's like the same thing, basically just with different addresses. So, okay. So now I'm gonna launch my cluster. Our systems are go. So you see here like all kinds of applications have been started and this interface, and this is kind of important. And this, because it's like CouchDB 2.0 uses airline, distributed airline, and the different nodes communicate via the airline, like protocol, message passing protocol, and so these addresses need to be different. So you must not have any name collisions. Okay, now I get a cluster, and it's even got a UI. So you see here it's 11, and 12, and 13. So I now created this database on some random cluster node. So you see here it's been created. And I even can create a document as like, yeah, you know that. But yeah, it's not on the other cluster nodes, so there's something missing actually. So in order for it to work, I need to configure a cluster membership. So that means the cluster, the different cluster nodes have to be aware of what node is part of the cluster. And I'm just gonna do that via curl, and it's, yeah, maybe I'm just gonna do it and explain it later. So here is, what? So I'm just doing that on the node 1, 11, and you see here, I'm not using 5984, but 5986 like port. And so there's some internal, like this is a internal HTTP interface, and it's got some internal cluster, internal database called nodes, and this the purpose of that is to store the node membership information. And so now I'm gonna add node 2 to, like, I'm gonna tell node 1, which is on address 11, I'm gonna tell that node 2 is part of this cluster. And so it works like creating a normal document, and I don't have to put anything in the document body, so I can just send some empty JSON. So, can you see that here? Not so much. So here you can see that the write did actually succeed. So nothing special. Actually, I'm gonna do the same for node 3. Okay, success. And now I'm gonna do the same like previously. I'm gonna add a new database, DB. And
Klaus, scale the
oh yeah.
screen so that we actually can see what you're doing.
Yeah, everything.
So you see here on the problem is like the address bar you can scale it. Sorry?
Down your browser.
Not full screen, but
Make it small.
The window.
The window of the browser, you can make it smaller, so it fits into the...
Okay. You mean like,
smaller.
okay, sorry. I can't figure that out right now, I'm sorry. Yeah, I'm using this window manager that's not like made for that actually. Now I can just move it. Like, the important information for you is just that like all the cluster nodes now have this database. Like DB is on node 3. So this crate actually succeeded also, like this database has created in node 3, node 2, and node 1, of course. And now, if now I'm gonna just yeah, write some document to some random cluster node, and let's see if it's replicated to the other cluster nodes as well. So I'm gonna pick node 2 and DB, just call the document 1 and just some empty JSON, whatever. Of course, I need to specify the port. Oops. Okay. So it's been created here, and so here you now get a document, and yeah, here you can see a futon that it's been created. Also on node 2, you get a document, and on node 3 as well. So what does happen when you have down, like when some node in your cluster is down? So I'm gonna write another document, and so yeah, it succeeded as well, like 201 created. So what happens if another node in the cluster goes down? And I again try to, like now we get only node 2 available, and I'm gonna again like try to put a document in the database. So that's kind of interesting. You don't get a 201 created, but you get a 202 accepted. So HTTP actually like handles kind of, the standard has like yeah, respects the case that there might be some operation that you can only accept, but you can't tell about the success or non-success of it. So, and CouchDB fully embraces HTTP, so here you can see it. And so just as a proof, like both nodes are down, only node 2. But as soon as I'm starting the nodes again, they gonna have the document like the same word view, like the same picture, and so they also have this document number 3, like this is the ID on node 1, like this document, and yeah, node 3 also got it. So I'm slowly getting to the end of my talk. I just wanted to like show you one more interesting thing that is like not currently possible, or like if you like new problem if you're going distributed. So let's just assume that we now have only one, like node 1 available, and we're just gonna put a new document to it. And let's say like now I put something into the document body foo true. Okay, you can, so here, you can see it. This is the body of the document. So, and I write it to node 1. Okay, now it also says 202 accepted. And sorry, I previously forgot to mention how this relates to CouchDB 2.0 configuration. It of course relates to this, I show it to you in the configuration file. It relates to this R parameter from here in the cluster. So if the if this write operation can only succeed on less than this number, this W number of nodes, it will return 202 accepted instead of 201 created. Just to make that clear. Okay, getting back to my experiment. So now I'm gonna take down node 1 and start node 3. Okay, and put a exactly this a document with exactly the same ID, foo-duck, to the database, but I just say foo false. So here you can see this is the body, document body, foo false, and let's see what happens. Yeah, so again the same result, but now if I start the other nodes in the cluster, it's gonna be interesting because we now got different views, world views, colliding, whatever, because this node 3 and node 1 have different versions of the same document, the same in the sense that they have the same ID. And so what happens if I asking the cluster node 2 whatever for this document? So, okay, the essential part is here. Yeah, so you get a conflict. So it says here, I just in order to demonstrate that I did a query with conflicts true. It's query parameter, and it will return, and the read operation it will return the information about document conflicts. So on here you got all conflicted, this array underscore conflicts. So this will just returns all the revision numbers of all conflicting document versions. So yeah, so this is handled nicely. So you got a deterministic CouchDB deterministically returns as you know it. It deterministically returns one of the document versions, and this might change in a after 2.0 in a future major version, because actually we want to return always all versions of it, because in a distributed system you can't say this is the right or the wrong version. You maybe want to give the client the chance to choose the version, the right version, or maybe there's no right version, maybe all versions are kind of right and the client wants to do a merge or whatever. And this is something you have to decide on the application level, how to handle this kind of problems. And so we probably want to give, we can't be smart, CouchDB can and won't try to be smarter than you as an application developer. So we will probably change that. Okay, so yeah, so I'm finished with my introduction to CouchDB 2.0 and hope you want to try it out some more. And any questions?
First of all, thanks a lot. Okay, just a quick info. We're just changing the laptop because now we have Frank. Also, he will show something else. And during this change, you can ask maybe 1 or 2 questions. And afterwards, just go ahead to Klaus and ask him everything you want.
Yeah, so I will be available.
Okay.
Yeah.
Just a second.
Okay, one question.
Yes.
So what I'm interested is, and I hope I got this wrong, this right from your presentation. If you have like 3 nodes and put a database on all these clustered nodes, and you add later on a 4th cluster node, so will this 4th cluster node be automatically rebalanced so that all clusters contain the same material? Because this is something that I know was not possible with Big Couch.
Yeah, definitely. So this feature does exist, but not in Apache CouchDB right now. So you have to, like, people like Cloud, and they have actually implemented that, and the plan is also to incorporate that into CouchDB 2.0. You need some tool for that at least. If it's not, probably it should be automatically. And if we can make it automatically for CouchDB 2.0, we want to document that and then give you some instructions and tools to handle that. Okay.
Okay, thanks a lot again, and we have to change microphone. Thanks.